the new trig function is arctangent. It's going to work very similar to arcsine and arccosine. In fact, it has one of those trig functions range, and you'll see in a moment. And the other thing is just getting into the next one. This is inverse trig composition. Now, this is pretty straightforward. I'll keep it as such, and hopefully just getting this down will help us go over the notes a little bit more formally on whenever we see each other, I think Wednesday. But I will keep it simple. I've uploaded a worksheet where you can do some practice problems. Please get them done and upload them. But for now, let's get started. So to get to the main talking point here, I just want to mention that inverse tangent or arctan, its range will be from negative pi over 2 to pi over 2. Now, if you've done this, you realize now that this is the same range as arcsine, and it is. So the only difference is that it's now tangent and it's y over x, right? Not x over r. So all you have to do is, just to sort of get to that faster, more efficient format of doing this type of problem, I would start off by, let me use a different color here, start off by using a graph, right? And then after that, I would just X the quadrants that don't work for me. So for those of you who haven't been practicing this is quadrant 3, quadrant 4. So if my interval only works between negative pi over 2 to pi over 2, then it's only able to be between here and here. That means that quadrant 2 is out and quadrant 3 is out. Now, I am going a little bit quicker, but you have to understand that I'm assuming you at least tried that other assignment. But if not, you can really pick it up just by looking at this video. So now with that being said, our job is to put the reference angle on this graph here, right? So first and foremost, I want to convert this so that I know what my y and my x is, right? So this is going to be radical 3 is my y, x is 1. So that means I have a triangle here, and it's going to be radical 3 over 1 here, and this is 2. So if you realize this is actually just a 60-degree or pi over 3 reference triangle. Now, let me make this clear. You do want to sort of just draw it here so that you can pay respect of where it's at, because that teaches you, hey, what are the two possible triangles? But let me just ask you why we can already say that this is going to be x, right? And look at the function itself. It's not going to work because it's not negative. If you look at the value, it's just positive. So it only is going to work for this top one, right? So now all we have to do is just take the degree. And this one's very straightforward because it was quadrant 1, right? There's no, oh, it's 150. We need to convert it back to reference angle, right? So in this case, it's just quadrant 1. So in this case, it's going to be that arc tangent radical 3 is going to literally just be pi over 3. That's it, right? So objective is draw the graph first, x the quadrants that won't work, right? So since it's arctan, x these, it could only be this, right? I put the little range there. If it's sine, it's also just these two, and then these get x'd. If it's arc cosine, these get checked, and then these right here get x'd, right? Because arc cosine, its range is from 0 to pi. Now, I highly recommend that you work with somebody if you are still unsure of how to do this. We need to really tackle this as a team. So the second one, please pause the video, try it out. But I'm going to go ahead and do it already. Right? So that's that. I can X these. This is not arctangent. Arctangent can only work here. Now, this one's going to be interesting because you're like, wait, tangent 0. If that's true, then it must be that my y over x is equal to 0 over 1. And I say 0 over 1 because if x is 0, remember, you'll get undefined. So the only way you can get 0 is if it's 0 over 1. So when you get a situation like this, just put it as a coordinate, always. So Yeah, 0, comma, no. 1, comma, 0, right? And so y is 0, x is 1. So the question now is, where is this? Where does this belong? And if you remember your coordinates, that's just right here. So what degrees is that, right? You could say 360, but just keep it simple and say 0. So in fact, the answer to this is literally tan inverse is equal to just what degrees is that, right? That's just 0 or 360 or 2 pi. Any of these would work, but oops, or 2 pi. Any of these would work. However, just keeping it simple is going to be the key here. 0 equals just 0, right? Now, again, this is not 0 as in the 0 that was in here, right? That's 0 as in this is a value 0. This is right here, 0, technically 0 degrees. So again, you could put 0 degrees, which is what you should always put. But if you need to, you could put 2 pi, right? But again, 0 is going to be the best thing. Actually, you don't want to use 2 pi because that means you went a full circle, but you hadn't even started, right? So again, just keep it simple and that'll be it. All right, that's it. Same thing. Again, I'm relying on you having done sine, arc sine, and arc cosine. So if you haven't yet, please work with others. But this is it. If not, watch the video, submit the first worksheet for partial credit, the one that you should have turned in yesterday. Let's do inverse trig composition real quick, please. This is actually not that bad at all. So just bear with me here, okay? So if we draw this little triangle here, this is going to be where you just need to go straight to drawing a triangle. So first of all, let's just draw this real quick. And again, as a reminder, this is y, this is r, because we are talking about arc sine. So y is 12, r is 13. And if you really need to know what this is, try to figure it out in your head. Otherwise, you need to do the Pythagorean theorem. So what I'm missing is x, right? So x squared plus y squared equals r squared. In this case, x squared plus y squared. I'm going to jump to the answer here, 144. And this, I believe, 13 squared is 169. So if I do x squared equals, and then I'm going to subtract 144 to both sides. So 169 minus 144, that's going to be, let me see, I believe that's 25, right? So 25, so that's 25. Then that means my x is equal to 5. Okay. All right. Correct me if I'm wrong, right? But I believe x is 5. So here's where we jump to the chase here, okay? Arc sine only works here and here, right? So first quadrant, fourth quadrant. However, if we look at our specific triangle, what do we notice again? It is all positive, so it's up here, right? Arc sine is all positive. Now, you might be like, well, how do we know or not know that x was negative? Well, when we did the math, right, we know that x was positive to begin with, and we weren't given something like, oh, by the way, cosine is negative, so we assume that it's positive. So then here we have 5, 12, 13, and then we'll go from there. So with that being said, right, this is pretty much it. So really your job now is this. Can we use this for tangent? Because now we've already established this, right? We established this by actually drawing it onto the graph, and we're done. But now the question, we move on now to tangent. Now, does tangent, can we use this triangle we just drew for tangent? And the answer to that is yes. When we write the answer for tangent, we must still abide by that. Hey, where does tangent exist, right? Tangent exists here and here as far as arctangent goes. But this one's going to suffice all requirements. So that's why we didn't even draw a triangle at the bottom to begin with. So when we draw that internal arc sine or arc cosine, just draw that triangle where it fits, right? And then from there, get the corresponding values that you're going to need. So with that being said, we have tangent sine inverse of 12 over 13 is equal to, now all we need to do really is just get what tangent is, sorry, and tangent is y over x, which it then becomes 12 over 5. And that's your answer, 12 over 5. Cool. Just keep it that simple, and then I will add 5 practice problems on this. Your job is to, I'm going to upload the answers, is to try to get close to the answers as possible. But again, we will continue this next class, but I will be looking at your what you upload to ensure that you even tried, and then give you credit for that, okay? So, good luck. Email me if you have any questions.